welcome to our first live stream of the year. So our live stream, sorry for the delay. There was a bit of a technical lag here going on, but yeah, so here we are and we are starting our first live stream of 2021. So Happy New Year, everyone. And thanks for joining this live stream. And yeah, so the topic of our live stream is public GitHub repositories for managing LCIA methods. And I will be your presenter, and Tim Lozu will be joining me as a co-presenter for today. So before we begin, let's just introduce ourselves. So I'm Salwa Burhan. I'm working as a sustainability consultant and data analyst at Green Delta. And Tim, would you like to introduce yourself?
Sure. Hi, my name is Tim Loza. I'm also working as sustainability consultant at Green Delta, just like Salwa.
All right, thank you, Tim. Yeah, and so before we proceed further, I think, I would just like to highlight some points about questions. If you have any questions, then please feel free to type them on the chat box on the right side, and then we'll take it during the dedicated question and answer time. Also, if you have any technical difficulties or issues, you can also type that in the chat box and we'll try to troubleshoot them if possible. And yes, this video is recorded and or we will upload it at in the next few days, hopefully. Yeah, so that's about it. So let's then start with the presentation. So the agenda for today's live stream is LCIA methods. So we'll basically give a brief outline of the LCIA methods that are present in Nexus in our that can be used with databases in OpenLCA to make LCA studies. Then what are the current LCIA management practices that we have for OpenLCA? Then what is our motivation for having GitHub, using GitHub public repository for management? So far we have not done that, but we had not done that in the past, but now we are moving in that direction, and why we are doing that and what's the need behind that. And so basically we'll give a brief introduction to GitHub too, but not just a little bit, because for someone who doesn't know about GitHub, but I'm guessing most of you know about it. And and then Tim will basically demonstrate what we are doing, how we are managing these LCIA methods on GitHub, how you can access this repository if you have a GitHub account, or if you don't, then how you can create one, how we can track these updates that we are making between the different versions of updates, and how we can create an issue or open an issue in case we have some comments or some errors that we see. So how we can fix that or highlight that on GitHub, and then we can, of course, at our end try to fix them, and then close the issue. Then further works, because this is something new that we're doing for the first time, and so of course there are still some things that need to be done, and and how we plan to what kind of things we want to add for the future. So that will be in further works, and then in the end we have discussion for Q&A. So let's dive in. So basically right now the latest version of OpenLCA LCIA method package is version 2.10. so that is, the previous version was 2.05. so now we have added some more methods in this. Like you can see here that we have a new method called crystal scarcity demand. This is for the first time released in OpenLCA for OpenLCA databases. And and other than that, we have all of these which we've always had for in the past method versions as well, package versions as well. So for example, for water footprint, we have aware, which is basically the available water remaining water footprint method. It's a midpoint method. And then we have also some other water footprint methods for like Boulay et al., Berger et al. Then we have all these other midpoint LCIA methods. For example, we have environmental footprint. We have the latest version, which is 3.0. We have ecological scarcity, TRACI for toxicity, EPD, also EN 15804. So these are some of the midpoint. Also, we have some endpoint methods like ecoindicator 99, and also Boulay et al. We have both midpoint and endpoint. So these are some of the methods that are there. You can also check them out on our Nexus website and in the method package when you import that in OpenLCA. So basically, if we talk a little bit about LCIAs, we won't be covering much here because, of course, this live stream is the focus of this live stream is more about the management of LCIA methods and not really about LCIA. So here we'll just maybe for users who are curious to know what's the difference between midpoint and endpoint. So we just wanted to show you. So in midpoint, these are the impact categories that are present. Basically, when you say midpoint, it's kind of assumed that this is somewhere in the pathway from inventory results to the end point, which is like damage to the area of protection. So when you say endpoint, basically it means how the impact of different categories, for example, if there's an increase in GHG emissions, so what is the impact of that on human health? So what's the damage on that area of protection? So here you can see that there are 3 areas of protection. This image has been taken from ILCD handbook for LCI frameworks. So, according to that, the 3 areas of protections are human health, natural environment, and natural resources. So basically, midpoint gives you just the effect of, for example, if you have an increased chemical concentration in water, so that kind of impact. But if you want to see that impact, how in the end, what's the impact on human health or on natural resources? So this is what endpoint gives you. So this was just a basic, difference between midpoint and endpoint. And then, then these are basically some of the impact categories that will be there that we are managing on GitHub. So I will just highlight a few of them, which is here on the list. Global warming potential basically is then the indicator which gives the warming potential for the increase in GHG gases. Acidification, exactly like the name suggests, that's the acid indicates the potential acidification on water or soil because of the increase in NOx or SOx emissions. For the depletion potential of stratospheric ozone layer, again, it's the same, it basically indicates what's the damage or destruction causing on the stratospheric ozone layer, because of these emissions of these into the air. And water uses, then the quantity of water remaining after water is used for human or aquatic ecosystems, then the remaining water. So this is something which indicates or indicated by water use. Then we have these 3 more categories. One is abiotic potential for non-fossil resources, and the other one is abiotic depletion potential for fossil. So basically it's showing you what's the now it's an indication for the depletion of these resources, which could be fossil or non-fossil minerals. Then in last we have here is eutrophication potential. So basically the accumulation of nutrients in the water bodies, which is not good for water. So that is the kind of potential. Eutrophication potential basically gives you an indication of that. And also we have some more impact categories that we've not highlighted here. For example, human toxicity and aquatic or marine life ecotoxicity. So these are not here in the impact categories, but of course for our management for LCIA methods, of course they are there, and then we will also see them during demonstration, which all impact categories we have and for which all methods we have. All right, so then when we talk about management, so what is the status quo, what's the current practice? So the current practice that we have is, like you all know, when you want to work with OpenLCA, the first place you go is Nexus openlca.org, and that's where you can find the method packages. So far, like I said, the most updated version of our method package that we have is 2.0. It's quite a comprehensive package, and it has all the methods that we saw earlier, and also many more that was not covered on the screen. And these methods, of course, are compatible with the databases that are available on Nexus, which can be used in OpenLCA. So you can see on the left-hand side of the screen, some of the databases are already mentioned there. For example, EcoInvent, AgriFootprint, AgriPolice. These are some of the few databases with which you can use the LCI method. But of course, some of them are not compatible. For example, Pasilka, because that is something that's a database that is focused on social life cycle assessment. So for that, we have a separate impact assessment method which comes built in with the database. And for our management of these LCIA methods, we are not so far for the moment considering these methods which are coming with the databases, but only our OpenLCA LCIA method package. Of course, we are then also keeping a log file, which you can see in the document section in Nexus. So far for 204 to 205 and then 205 to 210, we have had these. And this is one way that we have been doing our keeping an update of our methods if there are any changes in the characterization factors, if there are more elementary flows added in some methods and impact categories. So of course, that's the way we are doing it. So this is something which is done internally, and when the users see it, they only see the end result. So they only see, okay, this is the log file and these are the changes that have been made. But then it would really be interesting if the users could, see it at one dedicated place, and then the users can also raise issues if they see that there is some feedback they want to give, or if they see that if they don't agree with the impact categories or something. So of course it would be good to have, and that was basically our motivation and intention for why we chose to use GitHub. And so why exactly GitHub? Okay, so time for a short introduction. So GitHub, basically what is it? It's basically a very widely used platform for code hosting. So people like your friends, you, company colleagues, people, if you want to work in collaboration with each other and create codes which you can use to create your own projects. So GitHub is a platform that is used widely for such a purpose, and because you are using it together, of course it's very important that there's a version control. There's a way to track who made what changes and when it was made and how you can track it. So GitHub basically it gives you a platform to do all of these things, and this is why we also have it. We have our own repository. We have our GitHub. If you go to github.com/greendelta, you can see all of the code and the work that we have done using GitHub, and or we have hosted on GitHub, that can be seen there. So this is our repository for LCIA methods, and we call it greendelta/data, and that's where you can find all the LCIA methods that we are now basically hosting or there for our version control. And Tim will basically now demonstrate how sorry, how we are doing that and what exactly can we do on GitHub, what we've done so far. So Tim, would you like to continue from here? Thank you.
Yes, sure. Thank you, Salva. So what we think would be nice for our users and for people who are generally interested in this, if you're interested in seeing and tracking the updates that we make for our LCIA methods, you could create your own account on GitHub, which is free, so you can just sign up. And then you can join our data repository. And if you do that, then you would be able to track the changes that we make on the LCIA methods in each different categories. And you would be able to also raise issues. If you think you spot an error in one of the methods, you could actually raise an issue there, and then we are able to check and track this and basically have a version history of all this. So what I'm going to do now is just share my screen and show you how this actually looks like when you go into GitHub. Right, so now everybody should be able to see the screen. So this is the website that we made on GitHub. It's called Data, and these things then are called a repository on GitHub. And here we have a little folder with our LCIA methods. And what we did here is that to kind of test it and to showcase it, we uploaded the 2.05 version of our methods, which is the previous version. And then we updated it to the 2.10 version, which is the current version. And we're just going to show you how GitHub then shows the differences between the old and the new version, and yeah, what it looks like. So if you open this method folder here, you will see like this. You will see each and every impact category that we have for each and every method. If you're familiar with OpenLCA, we have the OpenLCA method package, and yeah, it features, I think it was 43 different methods, and in total this results in about 500 different impact categories that are all in here. The way we named them is by naming the name of the category and then saying the name of the method this belongs to. We're going to keep them here all in the same folder. What we're also going to do is, if we go here in the method folder, that we're going to link all these different categories in the different methods that are also featured here, which is just makes it easier for you to find them. But yeah, that doesn't change the underlying principle of how this works. So what we did here, we updated the 2.05 version, the old one, to the now 2.10 version. And you can see here that we made this update. And now I'm going to show you how GitHub compares the old and the new version next to each other and how it shows you the differences. GitHub doesn't call it differences, they just call it diff. And when you compare an old file to a new file, for example, it can look like here. GitHub understood that for this category called cadmium in this method here, this method is called selected LCI results. It understands that here in rows 2, 3, 4, and 5, there were some changes made. Mainly in this case that the ID here changed. For example, here we have a flow of cadmium of 1 kilogram in the old version. In the new version, we also have a flow of cadmium 1 kilogram, but the ID was changed. This is why these names are highlighted here in green. So this is basically how GitHub shows and tracks those changes. And we think this can be really useful for people who are just interested and want to know, hey, with the old and the new version, I get different results from my LCIA. What's the reason for it? So this is the one reason why we're doing it, so you can see it here. The other reason why we're doing it is the ability that we can raise issues. So sometimes it happens because there are so many categories and so many methods that we have. Sometimes one flow can be wrong. Maybe the value of the factor should be 2 and not 1 or something. So GitHub also gives you the ability to raise issues, which you can do on the same page. As you can see here, hang on, this is in the way. If you want to raise an issue, you can click here in the same data repository on issue, and then basically raise a new issue here. I already created a test issue to show you how this will work. If you click on raising a new issue here, you can basically write a text that describes the issue. And what we thought would be a good idea, if you basically paste the link in here of the specific impact category that you think has an error in them, and then you could basically say, okay, I think that the factor, for example, in line 164 should actually be 49 kilo. And then you just paste the link in there. And then we can use this link to actually see which specific impact category you meant, for example, this one here. And then we could have a look and see, okay, do we think this factor is actually wrong? Should we change it or not? We can basically check it. And when we fixed it, we can basically say, okay, we're going to close the issue here. And then we can write a comment and say, okay, we changed the factor from number A to number B. And then this issue is closed. And the good thing is that this information will then always be visible on GitHub. So the issues that have been raised in the past and have been closed in the past are also visible here under issues, under closed issues. And then you can basically see, okay, what fixes have we already made in the past? So no information is lost and everything is very transparent. And we think that works really well for quality improvement, because of the many eyes principle. Of course, if all our users are looking into this and point out potential errors, then yeah, we can ensure a higher quality of our LCIA methods. And generally, this is in line with our with the way that we think everything should be open source and more transparent. And yeah, we think this is a fair way to show our working process and to ensure high quality of our LCIA methods, basically. Right, so what we then would do here is basically, if you show us an issue here to say, I don't know, please change this vector, we think it's wrong. And then we would basically close this issue, and then this issue shows up in the closed issues that I showed you before. And yeah, that's basically how we think we can use issues for our quality control in LCIA. And I'm just going to check on the live stream if anybody has posted any questions yet. Not so far, but feel free to do so. So if you have any questions about how this process works, or generally about LCIA methods, feel free to write your questions in the chat window next to the stream. And yeah, that's basically how LCIA is going to work on GitHub. And maybe Salva, do you have anything to add to that, or? You're still on mute.
Hello again. Yeah. Thank you so much, Tim. Yeah, I can see we don't really have any questions so far. But yeah, I can go back to the slides until then. So share screen. Yes. Yes, can you see my screen now? Yeah.
Yeah, we can see it.
So yeah, so I hope everything that Tim explained is clear very far. To me it was, and yeah, I'm happy that we have set such a system now for tracking changes, so we are well aware where exactly we have made any, what are the changes or differences between the different versions of OpenLCA, and if we have any issues, how we can raise them. So that was very good. So now you saw that there are impact categories, for example, for what we are focusing on, but then we will eventually link them to the impact methods. Also, some of the methods comes with normalization and weighting factors. So if you are aware, these are the optional steps when you make an LCIA. So normalization and weighting is something which is optional. So because of that, not many or not all the LCIA methods have them, but some of them do. And it would be also good to, sorry, to have them in one place. So we will also add them on GitHub in the future. And of course, then we plan to release the documentation with the instructions. So basically what we have shown today in this live stream, we will also create a manual where all this information will be laid out. So you can use that in case you would also prefer to read and follow the instructions. Then, yeah, and if there are any other suggestions, please feel free to write to us. You can write it in the comments on the chats, or also you can write to us on our other social media platform like LinkedIn or or just our email ID. So with that, I think we can finally move on to the question answer session. And yeah, so do we have any questions here?
There's a bit of a delay between our stream and
Yeah.
our Zoom call, but so far there are no questions. So I hope that means that what we explained so far was really clear.
That's good news.
And yes, but if any questions come up, you can reach us on our other social media outlets or just on email. And of course, we're going to publish the explanation of what we did also in a document for those who prefer reading it. So yeah.
So then maybe let's wait for 2-3 minutes more to see if there are any questions before closing the session.
Sure.
Yeah.
Perhaps I can explain a little bit deeper what we mean when we say we want to link the categories to the methods. So I'm not sure if that was super clear.
Yeah, you can show that.
Just gonna do
I'll
that
stop
by
sharing
my screen again here. All right. So like I told you, we have this data repository on GitHub. And in that we have here the LCIA method folder. And in this folder, we have done two things. One thing we've done is down here, we have the categories folder that has all these 500 or more categories in it. And this is where they're located. And then we have the other folders, which are basically just the names of our different LCIA methods that we have. What we're going to do is, just to make it easier for everyone to find the categories that they're looking for, is that in this folder, we're going to create a list. And this list is basically just a collection of links of all the categories that belong to this particular method. So that's the idea behind it. But they're going to be actually physically located in this categories folder. Right. I'm checking the live stream again. I don't think there are any questions right now.
No, I can't see any either. So I guess it was pretty clear then. And yeah, I think we can then end the session here. Is there anything else that you would like to add, Tim?
No, I think we're good. So we're going to, of course, this is a live stream, but we're also going to re-upload the video and edit it and upload it on our YouTube channel. And then, yeah, the rest you should be able to see in the written PDF documentation. So, yeah, yes. Then I think we can say thank you for joining and watching. And we'll hear back from you shortly, and we'll be back with another live stream in, I think, 2 weeks.
All right. Thank you, everybody. Bye. Have a nice evening.